for just pulling together so many interesting topics and speakers and people to add to the conversation. Dan, it's been just phenomenal thing you've started here, and everybody here is, you know, I've listened on some prior talks, and boy, you get lots of participation, you get lots of good questions, and that follows through onto the group. So excellent. Some of this is going to be really basic. I expect most of you are HF operators already, so you probably know this, but just in case, I want to make sure everybody's clear on some of these topics so that you can take it back to your respective groups and help make sure they're doing this properly. All right, let me do a screen share. Hey, maybe. There it is. All right. Okay, is the screen visible to everybody?
It is, it is.
All right, and so let's rock and roll here. Okay, well, I'm Marty Wall, N6VI, and I am the past Vice Director for ARL Southwestern Division. That was for 9 years plus. And I'm also involved in emergency communications with the Fire Department's Auxiliary Communication Service in Los Angeles, which is a RACES type organization. And I'm Assistant DEC for ARES Los Angeles Northwest. I really, like some of you, started out as a novice on HF, and then pretty much stayed on HF for a long time. It was quite a few years before I got into VHF. So I do contesting from various places around the world, about 20 contest expeditions on 6 continents so far. And so I got to experience all sorts of interesting HF propagation. But today we're going to really talk about, starting with the HF side, we're going to talk about near vertical incidence Skywave. And what that really is a means of communicating regionally that does not require infrastructure and does not depend on you being up at a high spot where you have line of sight to your targets. Sorry, this is a California example, but you know, here in Los Angeles, we're looking at this range getting up to Sacramento, our state capital, and places in between. You know, how do we kind of spray RF into that area? And the answer, of course, is the ionosphere. We have surface and direct waves, which typically will go out 40 to 80 miles, but that won't cover the kind of range we're talking about. Sky waves, fortunately, can reach just about anywhere if the conditions are right. So the question is, where are they going to reach? And this is where knowledge of the propagation comes into play, and then some knowledge of antennas. And I think you had a discussion on antennas, on HF antennas for NVIS work a couple of weeks ago. So let's talk about this angle of incidence. Okay, for those of you who spent your youth in the school lounge instead of studying, this will become very familiar. You see with the yellow ball, you know, you hit the cushion at a very shallow angle, it's going to end up a considerable distance away. Whereas if you hit it at a steep angle, it's going to end up pretty close to where it started. Well, the same kind of thing happens with the ionosphere. Now, I'm going to be talking about kind of reflection, but really it's refraction. It's the same principle as when you're looking into a stream and you think you know where the fish is, but in fact he's a different place because the light is going from one density medium to another one, and it shifts or refracts there. But for all intents and purposes, we'll call it reflection for now. So here we have a signal heading up to the F layer of the ionosphere and then back down. And you see it takes off at a, maybe a 30-degree angle, and it comes back. In between, you've got what's called a skip zone. Now, if you can get the signal up at a higher angle, that skip zone gets smaller. And if you get it up at a high enough angle, it basically disappears. And so this kind of gives us a clue to what it is we're going to try to do in terms of covering an area reliably around your station. Now, there are some limitations, and you can define those limitations in terms of frequency, in terms of angle, and so on. The critical angle varies with the frequency. The higher the frequency, the lower the critical angle, the angle at which refraction will take place. So for any given frequency, there's an angle above which no refraction occurs. It just keeps going on into space. Correspondingly, there's a critical frequency above which a straight up signal does not come back down. It just goes on into space. We can illustrate this real briefly here. Here's 10 meters, and this is on a good part of the cycle on a good day. Those shallow angles will head out. And I mean, this is where, when 10's open, I mean, you were working all around the world. So enough of you, I'm sure, have been on long enough to remember that. And, you know, you're sitting there in the middle of the night working Africa on 10 meters. It was cool. But as the angle goes higher, the 10 meters signal does not refract, it just keeps going through. 15's a little better. A little higher angle will get refracted, and the higher ones from there won't. 20 meters, even more. 40 meters, and 80 and 160. So you can see that critical angle varies with frequency. So the conclusion is NVIS is really not for the high bands. 10 and 15 meters are always, if they're going to be refracted, it's at low angles, but almost never at high angles. 20 meter signal might be refracted if it goes straight up, but only at a high spot of a good sunspot cycle in the middle of the day when there's lots of solar activity. But even then, it's really not optimal. And, you know, when you think of having a tri-bander and so on, I've seen a lot of emergency communication facilities where they put up, you know, they tell the hams to put up what they want, and they put up, you know, tri-banders or, you know, whatever. Well, I'm not sure when they're actually going to use them, other than perhaps to reach some much longer distances. Just as an illustration, with my home with my little inverted V, this is what I've worked on 17 meters. Okay, you notice where the gap is. It's almost all within, you know, maybe, you know, 1,000 miles. A couple of years ago we had the Valley Disaster Preparedness Fair, and I put up a demonstration station on 20 meters. We were only open for 4 hours, but that happened to be the California QSO party weekend. And we had just a dipole and 100 watts and a battery. And again, you see most coverage through most of the country, but this big gap here in the Arizona, Nevada, Utah area, it's just because it takes too high an angle to bounce that close to me. So now that leaves the 160, 80, 60, and 40 meters. Now, which band will give you the best results? That's going to depend on the time of day, the time of year, and where we are in that solar cycle. And if you can understand and master this, you will be able to make very good choices. Back when the sunspots were good, this was a typical daytime chart, a daytime map for the critical frequency, FO, F2. That's the highest frequency that will sent straight up, that will come back down into the, you know, to the nearby area. And you can see that here we are in Southern California. We were right around 9 or 10 megahertz. Okay, so that meant 40 meters, of course. If you put that straight up, it came back down pretty reliably until well after sundown. And so that's where the old adage, you know, 40 in the day, 80 at night, came from. And I used to hear that all the time. But then when sunspots kind of went away, the adage stayed, but the propagation didn't. So here we are. This is in a low spot of the cycle, and here's our critical frequency. What's that map say? Well, that little light green is 5 megahertz. So during the day, anything much above 5 megahertz will not come back down if you send it straight up. So 40 is going to be kind of long. Those lower angles will propagate, the highest angles will not. The best illustration I can give you of this is the California OES weekly HF nets. They have two of them. One is Monday evenings on 75 meters. One is on Wednesday mornings on 40 meters. And the 40-meter net for years now, as we've been low part of the cycle, has been really difficult. I can hear the guys in Sacramento and north, but I can't hear anybody in the southern region, San Diego, LA, Orange area. And and I've told them that, you know, this is not the right band to use for this net for this time of year, and it becomes horrible. I mean, we have to trade off. The guys in the north call the people in the south. The guys in the south call people in the north. If you don't have a good relay on the other end of the state, it just doesn't work. So hopefully lesson learned. I was giving a talk like this to a Saturn annual meeting once, and a fellow was describing his NVIS antenna, and it was a full wave 40-meter loop up about 35, 40 feet. It was over a big a ground screen, and he said, I don't know why it doesn't work. And I said, wait about 5 years and it'll work great. He had a great system for the wrong band. So at nighttime, it gets even more limited. This is a not unusual situation. I've seen it worse than this. That yellow is 2 megahertz. Okay, and the arrow is pointing again to Southern California. And basically that means anything much above 2 megahertz is unlikely to propagate locally, within a few hundred miles. So even 80 meters is not necessarily going to be usable at night. You may have to go down to 160, and that's unfortunate because a lot of people don't have antennas for it, and that limits the number of stations that can participate. And I've seen this critical frequency go down to 1 megahertz. At that point, you might as well just tune your AM broadcast radio and listen to somebody who's a few hundred miles away. So if the lower frequencies are more often below the critical frequency, why don't we just use 160 meters all the time? Well, the answer is because there's another couple of layers in the ionosphere, the ever sporadic E layer below F, and then this D layer. Well, the D layer basically does one thing pretty well, and that is it absorbs RF. Okay, but it only absorbs RF when it's ionized, and because it's further down into our atmosphere, it's not right up near the top there. It absorbs less RF than the F layer does, or less solar radiation than the F layer does, and so once it ionizes during the day, it starts absorbing frequencies, and it absorbs lower frequencies better than it does higher frequencies. But at nighttime, when the radiation goes, it disappears, and that's one of the reasons that these low bands tend to be much better at night. If you think about when you've gone camping or out in the boonies and you've got your AM broadcast radio in your car, hopefully people still remember those. And at nighttime, and you'd be tuning around and you'd hear a station that's, for us in Southern Cali or out in the desert, you hear stations in Salt Lake City and New Mexico and places like that with no problem, and maybe beyond. And of course, in the daytime, it's all local. AM broadcast stations, just because of that, usually have a different requirement for pattern and or power at night than they do during the day to avoid co-channel interference. So the F layer is working kind of in the opposite direction of the D layer. The higher the frequency means you're getting to where there might be less reliable refraction. You're getting near the edge of what will be supported, a straight up signal coming back down. But you also have less absorption. So the signals are louder until they're not. And it goes the other way around too. If you go down in frequency, your reliability will increase, but the strength is going to be attenuated by the D layer. So this band selection is really critical, and you should plan on changing bands during the course of any given day if you're going to be on for an extended period of time. So for regional communications, where we are now in the sunspot cycle, it's basically 80 during the day and 160 at night. Um, and during the day, 80 or 60 meters is actually proven quite good for daytime communication. If that critical frequency is up around 5 or 6 megahertz, that's just about perfect for 60 meters. Now, let's say you have to reach outside the region. For example, you need to hit a Winlink gateway that is well outside your affected region at maybe 500 miles or more away in a large scale event. That's where you would be turning to 20 meters during the day and probably 40 meters at night. Because you don't need that, you're not looking for that high angle now, you're looking for that longer distance, which is a lower angle of takeoff. That greater distance is because you have a shallower skip angle. And the higher you're going, of course, the D layer is much less an issue in terms of absorption. And also it's much easier to get antennas to effective heights for long distance. You're trying to get an antenna up half a wavelength, so 30, 40 feet is fine on 20 meters to get out to Texas or Illinois or wherever you're going. And it's, you can do that even if you don't have a tower. Now let's switch a minute and talk about VHF. A lot of you probably, if you're involved in ARES or any other similar public service group, you probably have a lot of technicians. And what many of those technicians know is they have a handheld or a mobile radio. FM is the only mode they've ever used. And that's what all their exercises are on. That's what all their nets are on. And that's pretty much all they know. Now, until they upgrade, they're not going to be able to do some of the things that we just talked about a little earlier, which is a good reason to encourage them to upgrade, of course. But on the VHF and UHF bands, there's a lot more than FM, as some of you may know. I've also been a VHF, UHF, and microwave contester, done roving, done mountaintopping up through 10 gigahertz, talked to Dennis a few times there and on the microwaves. And we find that we can get some pretty good distances. I mean, I've worked multiple states on 2-meter sideband and 2-meter CW, as far east as Montana and as far west as Hawaii. But that's not what our EMCOMM group is going to have to do. It's going to be very much the same kind of communication as you currently do on FM. But there's a number of advantages once you're equipped for single sideband. First, of course, is that single sideband has a much lower duty cycle than FM. With FM, you hold the microphone down, and as long as you're holding it down, whether you're talking or not, the radio is putting out full power and drawing full current from whatever power source you happen to have available. So using this lower duty cycle mode of sideband, there's less strain on your system, the radios don't get as hot, and you don't drain your power sources fast, which is particularly important if you're on a limited power budget. When AC shore power is out. You can generally copy much weaker signals on sideband than you can on FM. So you have a better range, which can be helpful when people, especially where you have terrain challenges in your service area. Unlike FM, where if two people call at once, you just get a muddle most of the time, and maybe if you're lucky, one letter at the end where you can start to sort it out. On sideband, you can copy multiple callers easily. This is something that we're very used to when we do single sideband contesting, such as in CQ Worldwide or ARL sweepstakes. You can hear several stations and pull out one and have part of the next one ready to go, ready to call. And most important, I think, unlike the FM frequencies, there's loads of room on these bands for the weak signal work. Let me show you what I mean. On 2 meters voice, in our Southern California band plan, we have basically 27 designated FM simplex voice channels. Well, we've got probably, I think we have more than 10% of the hams in the country in California, and probably more than half of those are in the LA area, Southern California. So we're looking at easily over 10,000 hams, some of whom are going to want to get on, even if they're not part of an organized group. And so those simplex frequencies are going to become very jammed, as will the repeaters, of course, which typically can handle only one user at a time. But you have room for over 60 single sideband voice signals at the bottom of the band. That's a big improvement. It gets even better on 70 centimeters. Here, because of the prolific distribution of 70 centimeter repeaters, we really only have about 3 simplex voice channels on FM in that big segment. But if you go down to the 432 range, we have room for over 500 single sideband voice signals. This is huge. You could pretty much get a frequency and not worry about being interfered with or interfering with anybody else. Few additional advantages. The jammers with FM radios probably aren't going to find you because they really won't be able to hear you. I remember FM was designed to reject impulse noise from cars back when nobody had ignition noise suppression. And as such, it ignores basically AM amplitude-based signals, which a sideband is. So they're not going to find you with an FM radio generally. People with scanners probably won't find you because the scanners don't have capability to listen to sideband in most cases. So although it's never private on amateur radio, at least there's a little bit less you have to deal with there. When we're doing contesting on VHF and UHF sideband and CW, of course, most everybody's horizontally polarized, you use the big long Yagis, but for the kind of work you're doing here with EMCOMM, you don't really need that. In fact, since almost everybody in your group probably already has some form or several forms of vertically polarized antennas for 2 and 220 and 432 and maybe 1.2 gigs, that's what they're using, so there's no need to change. You've got almost a 30 dB, the engineers here can correct me, but I think it's almost a 30 dB penalty on a straight line signal without reflections when you have cross polarization. So it's you really want people on the same polarization of antenna, and since again they're using the verticals anyway for FM, there's nothing magic about that when you change modes. Just keep it vertical and it works okay. The practices in running a net or whatever you're going to do are different with FM and sideband. FM, of course, is channelized, which means they're either monitored or scanned, which means if you put out a call, it's a short call, people are either listening or they're not. The squelch keeps the radio silent when there's no signal, so you can make a short call and you'll get somebody's attention if they're there. Sideband is very different. The users tune across a range of frequencies. There's no squelch, so you've got some band noise in the background. But the only way they're going to find you is when you're transmitting and they tune across you. So you call CQ on the HF bands, you get random contacts or not. On VHF, you're probably not going to get too many random contacts, but if you agree to meet somebody on a particular frequency, they're going to have to tune you in and find you, and then you can resume, start making your information transfers. Now, tuning in a single sideband signal is probably trivial for most of you, but for your technicians who've only been on FM, it can be a real challenge. My wife has now been licensed for 10 years plus, and when she started out, I wanted to introduce her to sideband, so I sat her down on 6 meters, and she started chasing 6 meter states, and she got about 30 of them or so before the band kind of died. And in the process, at first she was overshooting one way and overshooting the other. It's something most of us take for granted, that the new ham the tech, the person who's only been on FM will not know anything about. It's going to seem very frustrating to them. So you're going to have to do some coaching and some examples. And unlike FM, where I'd say I just meet you on this channel or meet you on this frequency or this repeater, when you give them a frequency on say 2 meter sideband, that's going to get you close, but not necessarily close enough. You know, for FM nets, if you're a couple of kilohertz off, nobody really notices because you've got a 7 or 8 kilohertz bandwidth, and you know, you tune off. Try that with your multi-mode radio. Tune off a couple of kilohertz, and you'll find that it really doesn't matter. You can hear them; they can hear you just fine. But if you're a couple of kilohertz off on single sideband, you're basically not even there, and you're not going to hear anybody. So you have to tune around a little bit. Not all, particularly in VHF and UHF, not all radios frequency readouts are calibrated the same way. It's easy to be off a little bit. I mean, all these oscillators are getting multiplied up, and so you know, you can miss it a little bit. And I've run nets where I tell people I'm on approximately, say, 144.240, but find me, tune me in. And there are some people who insist on putting where their radio says is 240, and they refuse to budge, and as a result, it's really frustrating. So, I mean, having an RIT in the thing helps, but we try to get them trained to tune in net control so that he or she sounds like they normally would in person or on FM, and then you're on frequency. So that's something that you need to get them trained on. So that's pretty much the formal stuff. Why don't we kill the screen share and take some questions or comments or suggestions or your own observations. And
again, at the bottom of your screen, bottom of your participation thing, we click on that, it brings up a list. Down at the bottom of that, you can see where you can raise your hand. Raise your hand and we'll get you going in here in the questions. We got iPad, who never changed his name, in there. So iPad, why don't you take it away?
You'll have to unmute yourself. Or let's see, maybe I can do it.
No, I think.
Does iPad know who he is?
Yeah, we talked to him earlier.
Okay, well, why don't we skip and go to, we'll come back to him.
How about, ahead, you call him out.
Okay, how about Oscar?
Hello, actually, Marty, that's an excellent presentation. You expressed several things missing there. Coming from an island like Puerto Rico and the Caribbean and Virgin Islands, we have the same problem. And we need to get our communications within the region of impact, and there's no region after there's a sea. And this is the same case of Hawaii. So you see the team from the ARRL that they are using MBS antennas and Winlink at the Hawaii as well. They have to go in 40, 80 meters and also 160 meters to survive due to the kind of hills or mountains and the peaks that they have there that give a lot of shade and shadowing. And you have to struggle with that, even that it's difficult to have the only 60 meters antenna, you have to make it and put it in service. But it does work, and you are right on the point, and those are, again, we need to practice. And the only way that you learn these things and put into practice, everybody here need to practice at different time and so on, and learn the propagation during the day, and because of the delay, your absorption, and during the night, because it's not enough refraction from the antennas to get it into the impact zone. So once you learn all these tricks, you will be able to swap it and just simply change frequencies or bands, and you will be able to get your communications through. Thank you, Marty. Actually, it's a very positive comment that I'm trying to give you, because you did it. You have done a great job.
Well, thank you, Oscar. Nice to see you again. I think we met when we were in Florida, and good to talk to you there. And you know, you make a good point about having to practice, as is the case with most EMCOMM skills. And one of the things we used to do, and lately there hasn't been as much of it, is when we had a major exercise, such as our statewide medical exercise, we'd put, we'd have the usual VHF, UHF capability, but we'd try and operate from a few parking lots with the HF. And we try to pair up an experienced HF operator with somebody who's either new to it or not licensed yet for HF operation, and give them some exposure to how it works. And the fact that, yes, it doesn't sound as clean as FM on a repeater, but there's no repeater, there's no anything between you and the station you're talking to. It's just RF. And, once they see that, some of them, not all, but some of them will get the picture that, hey, this is valuable and I should upgrade myself and learn to do this. So try to pair up the folks that haven't never seen that before with the ones that are experienced, and they can get some good benefit out of that. Thank you. Let's see if iPad is back.
Okay, you must be referring to me, right?
Yes, sir. Okay.
My observation is that we do too many portable operations, SETs, and we're using FM, and sometimes it's simplex, but we need to go out and also put up HF antennas and operate that way, because we may need that sometime, not just local FM.
Yeah, and we actually, our ACS group did, in addition to our usual field day where we always set up ahead, this year being an exception, of course, and we get as many of our folks out to come and help so that they themselves can see the process of getting a portable HF antenna in the air, what it takes to do it, watch how we do it, make sure we do it safely. And then he's had some supplemental little sessions where we go out to a park or something, and a couple of people set up HF antennas, and the newbies come and watch and learn. So yeah, that's a good point. Thank you. Let's see. Next is Tom Horn.
Thank you, sir. In terms of, you call out to a hospital or someplace to support them, what kind of antenna, if you've got to be on 160 meters, is likely to be effective that you can actually get up in a short time?
Okay, good question. Okay, first thing, you may, I assume it was covered in Mike Ritz's talk, that you don't want to put up a vertical of any kind, because verticals have nulls going straight up, which is right where you want the signal, right? So a horizontal antenna low. Now I run the ARL Southwestern Division net. Some of you check into that regularly from some goodly distance. I usually have a pretty good signal. I'm one of the loudest guys on the Cal OES net. This is 75 meters, and my antenna is basically an inverted V with the apex hung from a tree at about 30 feet and the ends about 6 feet off the ground. So if you take that as a model for something that does work, and add maybe a little bit of height, maybe not. I mean, it could be pretty low and still work. So if you could get a full-size dipole up and string it between a couple of trees or a tree in a building, or light fixtures. If you're out at a hospital, often they have these nice big tall light fixtures that that are spaced around the parking lot. I have a pneumatic tennis ball launcher that I made. We used it for field day and so on for stringing dipoles. If I can pop that puppy over one of those cross arms on the light pole, I've got an antenna support right there. So, but don't think you have to get it 50 or 60 feet in the air. You really don't. Efficiency may change, but just put it up and see if it works. And you may find that if it's 10 or 15 feet off the ground, it'll probably still work. It may be a kind of a load on your radio. You may have to use the auto tuner, but it'll probably work for what you're trying to do. Is it good enough?
Okay, so our particular kit includes a 50-foot surplus mast and ANGRA 50s, which will go below 160 and all the way down to 2 if you want to be really ridiculous. because they're variable length. So if we just put that puppy up and then put a 160 off of it, we're likely to be okay?
Yeah, I think so. Now, remember, when you have stations in the field, if you have some sort of central location, and I don't know if this was covered in the antenna side of things, but if you have some sort of central location, command post, net control, whatever it is, if that place can have a fairly efficient antenna, ideally like a loop with a ground screen under it and so on, it will help make up for some of the less efficient antennas that are deployed portably out in the field. So think about it, the whole system from a strategic standpoint. Not everybody has to have an ideal antenna system. As long as you can hear somebody, it's sort of like moon bounce. I can work W5UN with his 280 elements if I have, 2 Yagis. So the gain on one end makes up for the lack of gain on the other end. And there are some good designs, especially if you're looking at a fixed location like an EOC, if they have a parking lot or something where you could have antennas maybe not in place but ready to haul up on some pulleys, that would be better than the typical field installation. That will make up for suboptimal field installations.
Now, if I cross two 160s with ANGRA 50s, that's real easy to do on the same mast. Am I any better off?
Well, if you're going to, I know, normally not, because, once the signal hits the ionosphere, it comes back basically elliptically polarized. And that means it could be clockwise, the ordinary wave could be counterclockwise, the extraordinary wave, but it's not going to be, the orientation really doesn't matter that much. Mine is almost, my 80-meter dipole is almost end on to Northern California, and they hear me great. I'm one of the loudest stations up there with just this little inverted V. So don't worry about orientation. If you do have that capability, what I would consider is putting up your 160 and then crossways put your 80, your 75. So now you're set up for day and night.
We've done that a lot, and I do know the advantages of that. I was just concerned at 160 how we might improve.
Now, the best improvement would be if you can get it, if you can get it fairly high. I mean, remember, 3/8 of a wavelength is considered, that's about the maximum height for NVIS. And then you're going to go to a low horizon type pattern. So you want to keep it between 1/4, 3/8 of a wavelength if you can. But even, a 1/4 wavelength on 160 is over 100 feet. So you're in no danger of getting it too high. But you can, if you can get the ends up a bit, and if you can, again, if you're operating at a place where you could put a ground screen under it, on a semi-permanent basis, like buried in the turf or something, that would be great. Usually that's not practical. I was always wondering whether you could just lay another one, like a reflector on the ground and make it point up. But L.B. Sebic, W4RNL, who wrote a lot of articles for QST and other magazines, did some modeling and shows that basically a single reflective element on the ground over under a low band dipole really doesn't do much of anything, so don't waste your time. So I would say, though, have a tuner on the radio if you can. That will help make up for whatever mismatch there may be because of the proximity to the ground.
We're using couplers out at the feed point on the mast,
okay,
rather than the tuners in the radio. And for field day, when we had all the time in the world, several field days ago, admittedly, we ran chicken wire out under a Shirley array, and certainly that was wonderful, but that's not something you're going to throw up in an emergency. A Shirley array is a pretty complex arrangement. So,
yeah. Okay, let's see. Who else has their hand up here?
Nobody's got their hand up.
I don't
Barry,
see any.
Yeah, Barry, do you see anything in the chat for a question?
Someone wants to know your opinion on the buddy poll. I'm not sure to that, but
unless you've got an enormous bladder, you're not going to get enough area wet to make a difference.
okay.
If you got a herd of horses, maybe they'll do it.
Marty, this is Mike Lavender.
Hey, Mike.
Hi. Did you say earlier in your broadcast that vertical polarization is okay on FM and SSB?
Sure. The hams that do DXing use horizontal just because, well, probably several reasons, but one is they tend to be perhaps a little less susceptible to local noise sources, impulse noise. But again, if the number of people in your group that have horizontal 2-meter antennas in place along with verticals is probably fairly low. And so by picking the horizontal that the DX guys use, you're going to exclude a lot of your members or cause them not to be heard very well. So it's better. I mean, there's nothing magical about the polarization versus the mode. It's more what's common usage. And since, as I say, especially if you got people out mobile, by definition, most of those, unless they've got a Squalo or one of those on the car, most of them have some sort of vertically polarized whip. Well, you're going to want to be able to communicate with them. So again, try to match what everybody else is using. And by everybody sticking with vertical, you don't need to change it. Nobody needs to change antennas when you change modes.
Thank you so much.
Right.
I got one more chat room. What is the best or reception/transmission solution for getting reception when you're located in a hole?
Okay. Are we talking about HF now or VHF?
He doesn't say, so you can do both.
Okay. So what is the best strategy when you're in a hole, an RF hole?
Mm-hmm.
Okay, well, on NVIS using HF, it doesn't matter because remember, you're shooting the signal straight up. That's one of the advantages. It really is almost independent of terrain. On VHF, it's going to be a problem unless you can relay. And if VHF is critical and you have terrain issues, what our groups do is typically we'll have one or more stations at key high spots, like in the Santa Monica Mountains or somewhere that can see into the LA Basin and the Valley. Some of you can see out into Simi Valley and the San Fernando Valley. So you get a couple of stations up there who either are serving as net control or they can relay for those who can't be heard between point A and point B. There's really nothing magic you can do if you're down in a gully and you just have 2 meters.
Okay, we got Don over here, W0AF, who in Iowa has got his hand up.
All righty, Don, go ahead.
Yeah, just a comment about the 2-meter sideband. We started a 2-meter sideband net. It's been about a year now, maybe a little longer. And we did it, we were experimenting with Aries, and if the repeaters go down, we were seeing if we could get out with simplex. Didn't work at all. We're in the hills up here. And with the same locations on sideband, we get tons of coverage, and we're all running vertical because everybody's got a mag mount on their car or something, so.
Mm-hmm.
And it's been working great for us. We get 70, well, we have regular, it hasn't been on in a while, but one gentleman about 70 miles from us, north of us, he gets on. And so it's been working good for us as a side to an emergency and where the repeaters are down and we're mobile.
That's excellent proof of concept then. And it's good that you have so many of your operators who are properly equipped. And by the way, that's obviously an issue, hey, my Baofeng won't do sideband or my new dual band mobile radio won't do sideband. Yes, it takes something different. And there are, for those who have HF radios, there's the transverter route, maybe a little cumbersome for mobile or portable operation, but certainly for home use that will work. Although I've used transverters, all over the place in roving and everything, but it's not something that most people are going to have handy. There are, a number of radios that are all mode that cover 2 meters and preferably 70 centimeter too. As I mentioned earlier, 70 centimeters has so much room. And the propagation is usually pretty good. And it's also better than 2 meters for getting in and out of buildings. Although 1.2 gigs is actually the best for getting in and out of buildings. I don't know how many of you use that, but 1.2 is really magical. I mean, we did a hospital drill once. My wife was at the inside at their command post, and I was up on the roof of the parking structure to relay down to our medical alert center. And they moved their command post from just inside the big glass doors down into another building in the basement in the middle of the building. And she had her 1.2 handheld, I had a radio, and we had solid comms. It was absolutely no problem. I know in similar situations, trying to do that with 2 meters or even 70 centimeters would be, would be really problematic. So, I neglected to mention that in the presentation, but don't overlook 1.2 gigs. It can be very, very useful. Also very useful if you have a capable mobile radio and you have to leave your car. If you can get a radio little crossband between 1.2 and whatever your operational band is for the rest of the group, 2 meters or whether it's repeater or whatever. Now it's like having a wireless speaker mic that you're carrying around with you, and you're in the middle of a fire station or wherever else, and you can talk and it comes out your car and you hear what's going on from the car back down to your radio. Incredibly handy sometimes. Let's see, somebody had a question in the chat and it flashed and then it's gone, so let me see if I can find it again, or unless somebody picked that up.
What about 6 meters?
6 meters, that was the question. I know the Kaiser Permanente Hospital Group uses 6 meters as one of their primary frequencies here in Southern California. Not as many hams use it. For one thing, an efficient antenna on 6 meters is getting a little big for mobile operation. It's, I mean, you're talking about a really efficient antenna is about 5 feet long. Although you can take a 5/8 wave 2 meters and fake it for if you're not running too much power. But not as many, just given the kind of equipment that's out there for most newer hams, typically it's 2 meters and 70 centimeters. So if they have a multi-mode radio like, a 756 or an FT857 or 817 or some of the newer radios coming out now, they'll have 6 meters. Sure, if you've got an antenna, try it. On sideband, it will be, at least right now, the way conditions are, you'll have a lot of room. You'll have a lot of room to yourself. And on FM, it depends on the band plan in your area. There are some designated number of simplex frequencies that you can use. I think 52.525 is the national calling frequency on 6 meter FM, but that's, it's worth trying, but I don't know that it has that much advantage over 2 meters. It might, get over some hills a little better, but I'm not sure that that's necessarily the case. You'd have to experiment a little bit. Anybody have any experience with that?
They used to have Gonset communicators on 6 meter AM that they used.
Goonie birds. Yeah.
So it works.
All right, very good. Okay.
You're dating yourself, Marty.
Huh?
You're dating yourself.
No, they were already on the used market when I became a ham. I've only been licensed 53 years. So I'm a new guy. Okay, let's see. I see Nancy saying hello to Clara. Hello back.
How much power did you use in the 1.2 gigahertz radio?
Most of those radios, if they're mobile radios, FM, they have typically 1 watt on low power and 10 watts on high power. If they're handhelds, it's typically about 10 dB down from there. It's maybe 1/10 of a watt or 2/10 of a watt on low power and 1 watt on high power. And part of the reason for that is that the devices that are used to amplify the signal are much less efficient as you get way up in frequency. Dennis, is that right? Yeah. Okay, and
I'm sorry, Marty. I was reading something here and I missed what you asked me.
he asked about the power levels on the 1.2 radios, and I said that as you go up in that frequency range, the efficiency of the devices used to amplify is lower.
True.
And so they have more heat to deal with, and you have more power drain on your battery. So for that reason, they don't really make them the same range as the VHF UHF handhelds.
True, but if you're using one of the nice things about 1296 is the antennas are a lot more compact. If you're horizontal like a Yagi, they're very small, and so you can get a lot of gain with very, very low power.
Yeah.
So
at my at home I have a Diamond X6000A, which is 2 meters, 440 and 1.2. And of course, as you go up in frequency, the number of segments that it employs goes up, and therefore the amount of gain goes up as well. So it kind of lays out a nice pancake pattern. I just in the VHF contest a couple of weeks ago, I just got on casually to hand out contacts, but with my vertical on the roof from LA, north end of LA in the San Fernando Valley, I worked Bruce KG6IYN down in San Diego, the SEC down there on 1.2 FM with 10 watts. So yeah, good point, Dennis. Thank you. Other questions, comments, anything?
Replacement for the FG857 because it's discontinued.
eBay. I don't know. I really honestly don't keep up. I know that ICOM has their 705 coming out, which looks like a really nice radio, except that I think it's only 10 or 15 watts. So that may or may not be enough for the job you have at hand. Otherwise, it looks like a really nice piece of equipment. But I don't keep up on current manufacturers and what's coming out next, because I've got too many radios already. And if you don't believe me, ask my wife.
Okay.
Okay, Oscar, I'm going to have to mute you.
That's okay. That's okay. I'll take a laugh.
No, I missed a comment that Joe Speroni, the section manager from Hawaii, he was requesting the band plan committee to get the digital wideband into 160 meters for the same reason that we need 160 meters during the nighttime, sort of to keep the emergency communication, because we only have narrowband over there, 300 hertz, and that's that. And if they go wideband, it will be much better. Actually, we can keep a good bandwidth and communication. We gave a seminar of BARA by Joe Jose Nieto Ross about a month and a half ago. And he's playing his digital modes that more bandwidth, less power you need. You get a much better signal to noise.
Is this for Winlink?
This is for Winlink. It can be used also. He's working right now even into a DGP type. So it could be a station not connected into the internet at all. So this is actually an experimental that is becoming the breakthrough in digital communication by increasing the number of symbols. With 49 symbols and let's say 49 baud and 59 symbols, you can get about 7 kilobytes, which is very good. So you're making a breakthrough but you need the bandwidth. I mean, you need 2.3 kilohertz, which is not bad, but it's actually single sideband. So this is Joe also already wrote to the committee about it, but we should push that again to get the wideband digital mode in 160 for emergency communication. And I forgot to mention that.
Good. Well, let's hope that some of that makes progress. I wish that we had. Well, first, the ARRL actually put in a request to change the rules with respect to digital signals in the HF bands. Back when I was vice director, this probably goes back 6 years or so, and the FCC's been pretty much sitting on it since then. And then, of course, you've seen a lot of back and forth among the proponents and a few opponents. I think there have been some very misguided arguments in some cases, but the truth is that the FCC, I think, does recognize the fact that these modes do provide us the ability to give valuable services. And I'm hoping that there will be less restrictions, not more. And we won't have to worry about getting special authorizations to do something that the rest of the world has been doing already for a long time. Just my personal opinion.
Yeah, but if you, just to answer that comment in a positive way, if you use the beta software modem with a very low symbols, like less than 60 baud, you get so much bandwidth out of it, and you don't have to change any rules. So we don't have to wait for changing rules to go into high-speed digital modes in the HF.
Okay, okay. Anything else from anybody?
Larry,
Okay.
did you see anything?
Oh, nothing more in the chat. Someone recommended a Kenwood TS 700, which is also discontinued.
I've got one. Yep, TS 700. I had a slide for my local folks with a in this presentation with a list of radios that do various things. I didn't include it here, but you know that all the manufacturers at one time or another had a radio that would or several radios that would do all modes on VHF and UHF, and in fact that TS 700 is what I originally used as my IF radio for microwave stuff. And when I had the pleasure once of visiting Dave Blakeslee, W5UN, who had probably the world's biggest private EME array on 2 meters down in Texas one year, he was using a TS 700 for his basic radio. So they're venerable old radios. And again, there were some later versions, and other manufacturers have had things coming and going. For home use, don't overlook the idea of a good transverter. There are some wonderfully performing transverters out there where you'd have an IF of maybe either 10 meters or 20 meters. And there now you have all the features and interference reduction capability and so on of your nice, whether it's K3 or some other nice HF radio, translated up to the VHF or UHF band of choice.
I guess that leaves the ICOM IC7100 then.
There you go. I mean, you remember there were, you had the Yaesu. Yaesu had a whole line of radios, several of them that had bands and modules you could plug in and so on. So keep an eye out. I think, some of the newer radios are going to have that capability, especially now if they have HF, that means by definition they have sideband and all the other modes you're used to. And so if it's an HF radio that's added 2 meters and 70 centimeters, and maybe even more, some of them have 1.2 as options or built-ins, like the TS2000X, then you've got that capability in that radio. So anyway, I think looks like we pretty much exhausted everything. Dan, shall we turn it back to you?
I guess so. Okay.
Thank you.
Okay, now my wife came in, she's having some computer problems, and she was pointing it out to me. Anyway, yeah, it's a real good presentation. I appreciate it, Marty. I'm going to have you come on more often.
Well, it's my pleasure, and good to see some friends here from all around the country. It's terrific.
This has been rewarding through Zoom and the various Zoom sessions we have. Let me get my own video going. We've gotten to see and make a lot of good friends all over the place. Some of them we've worked on the radio, some of them we have not. It's been a great experience. I've enjoyed it, and I think a lot of the others have. It's kind of nice to put a face to a call sign or a face to a name, and it works out well.
I don't know. I've been told I have a face for radio.
Okay. For all you to know, we're recording this, and I will send out a link to the video when we're done, and I also will include, because there's a lot of good information going on in chat, so I'll include a copy of that so you all have what went on tonight. Are there any more questions, any more answers, or whatever for this Zoom session?
Just want to thank you, Marty, for presenting this.
Oh, nice to see you, Steve, and thank you. It's it really is fun to synthesize all the stuff that I've had the benefit of learning from other hams and try and put it all in one place and make it easy to digest. And it's as I say, I recognize a whole bunch of faces here from past personal contacts. So again, good to see so many of you, and not even having to worry about wearing a mask.
How true, how true. Okay, well, we'll go out here again. Any more questions or comments?
I just
I'll
saw
ask
somebody in a chat that said they had a question above that didn't get answered. So
Okay.
let's see, MP2SX. Let's see if we can find it.
Well, maybe he can come on here. MP2SX, you want to come on and talk to us?
Here he is. It says, what's the best antenna for reception and transmission solution for getting reception when you're located in a hole? I think we answered that.
Yeah.
Yeah, and you know, that low dipole on your NVIS band of choice will work fine because the signal goes up and it doesn't matter that you're in a hole. You know, one of those things in a hole in a valley and one of those things on a hill work pretty much the same, except the one on the hill will have a little more ground wave.
Could you text in the chat what the description that you just mentioned a while ago so I can look it up?
Yeah, I'll tell you what. Why don't I get something to Dan that he can pass around, and he can send it to the group? How would that be?
That would be great. Do that. And also, if you can, send your presentation and we'll get that out to everybody.
Okay.
Okay. Thank you.
We'll do that. Yeah, but we're basically we're just really talking about a dipole or an inverted V. You know, half wavelength long, quarter on each side, preferably fed, you know, with coax and some kind of choke to keep the RF from going down the coax, and that's it. I mean, you could build one for, you know, $20.
Okay. I'm kind of, this is my first time as well too. I'm actually tech transitioning to general.
Oh, excellent. Congratulations.
So this is to me. Father and myself were also, he's not on tonight, but he also having the same similar situation.
Okay.
So it'll be good to know what is good because we've been having to travel out of our locations to try to go different places on island to try to get some sort of a proper transmission or reception, but different places it's been difficult. Yeah, sometimes we can hear, but others can't hear us clearly.
Yeah. Do you know Fred NP2X? K9VV? Yes. Okay, yes. Fred's a longtime friend as well, and he could probably give you some guidance because he's a very experienced HF guy. Very experienced.
Usually he's on these things. Usually you find him on here.
Okay, very good. Well, Dan, thank you again for the opportunity, and great to see everybody. And I hope it's been helpful. And go out and preach the gospel, guys.
Yeah, hang on before you go. It looks like Thomas has a question.
Unmute yourself, Thomas.
Yeah, KF7RSF. Unmute yourself, please.
Still no audio.
Yeah.
I see you're unmuted, but you're not coming through.
He's just shy.
No. Is it in the chat or?
No.
No.
Thomas, put it in the chat now. I'll do it.
Okay. I don't see anything else. Thomas, I'm hoping is going to put his question in the chat.
So
or
let's give him a minute.
If he types like I do, it may take a minute.
Yeah. Give him a minute.
Are you one finger or are you two finger like me?
Actually, two and the occasional thumb. Yeah, Dennis, by the way, DQ on the chat mentioned that the EMCOMM IC9700 is a really nice VHF UHF multimode radio. Includes 1.2 gigs, and I believe it's made for satellite too, so it has some of the fancy features of automatic Doppler adjust and so on. But I know one of our Aries members got one, and he's been having a ball with the thing. Again, not inexpensive, but you know, I don't know about you, but when I get a radio, I try to pick it carefully, and then I hang on to it for decades. So when you look at it, sort of like this $50 license fee some people are worried about, you know, you spread it over 10 years. In this case, you spend a good radio thing over a couple of decades. It really isn't that bad when you think of it that way.
I'm gonna have to use that one for my wife for the next radio.
I got a question.
Yes, Barry.
Can we get a list of good sources for learning about MUF, FOF, etc. to study before we need to actually implement something like that for real?
Yeah, there are a number of good tutorials out there. I don't have a list of them right at hand, but let's see if we can dig some up. In fact, if anybody else has some handy, send those maybe to Dan as well, Dan, if you don't mind, and then
no problem.
Let's get a batch of links out there that that people can use. Carl Leutzelschwab, who's now I think vice director for the Central Division of ARRL, and you know, prolific columnist, has done a lot of research on HF propagation. Some really esoteric stuff, but I think he's got some good training on the basics as well. And I don't know how many of you watch the Solar Weather Lady on YouTube or on the QRZ. Tamitha Skov talks a lot about what's going on in the sun, which can help you relate to what's going on down here and maybe help you anticipate, you know, unusual conditions.
Okay. There's one more question. Do you
Yes.
need a extra loading coil to allow the legs of the inverted V to be shorter than optimum, or the feed point of smoke tuner?
Yes, loading coils at the ends. Remember that most of the current is in the middle of the antenna, so it's better if you can to put the loading coils at the end. In fact, when I was a youngster and had an inverted V for 80, that's what I did. I took some PVC and wound a bunch of coils and hung them off the ends, and that's how I got on 160. And sure enough, I worked all my neighbors, and that was about it. But you know, again, it was NV. We were doing NVIS. We just didn't know it. We didn't know what it was called, and you know, we were trying to work multipliers in a DX contest, but that didn't happen too much unless they had really good ears. But yes, the loading coils will work at the end. Obviously, anytime you're loading an antenna, you will reduce its bandwidth, and 160 is kind of a beast if you really have to cover a lot of area, because you know, every 50 kilohertz is a big percentage of your total frequency. So for example, we ended up putting up an inverted V on one of our fire stations, the only 160 antenna on any city facility that I know of in LA. And I cut it for the OES operational frequencies up around 1970, but I put some power poles on the end and an extra set of insulators and wire so that I could clip them in and bring it down to like 1830, where I could do some more interesting to me operations. So, you know, sometimes that just, you know, tacking in links, you know, to the end, make it easy to do. You know, you have a strain insulator, a couple of tails, you put power poles on them or whatever. And remember too that at the ends of the dipole, you have high voltage. And so, you know, make sure you have good insulated wire, you know, enamel wire or whatever. Kind of watch your spacing and your power and so on, because you could conceivably arc things over when you're out at that high voltage end of the dipole.
Good suggestions. Thomas, you have a question here? You got your hand up.
Yes, sir, I do. Something I mentioned previously, but think folks might want to hear. If you're at a facility that has a concrete driveway or any large concrete area, it's going to have some metal mesh in it. I mean, it's just, these days they don't do it without it. And that makes a hell of a reflector for these NVIS antennas. We had fantastic results being on the roof of a garage, setting up 80 and 40 a couple of years ago. And we couldn't puzzle it out because we were so much stronger than everybody. Well, we had that concrete deck with all that reinforcing steel under our antennas. So,
all right,
for what that's worth.
Yeah. Now the traditional rebar stuff may be just loosely tied together, so it probably doesn't function as a good ground screen because it's a bunch of separate pieces effectively. But if it's the steel mesh, I think it's all kind of welded together. So now you kind of have a continuous, continuous conductors down there.
Well, I was in the construction biz and as an electrician, and when they're doing those decks, multiple levels for vehicles, they tie the steel really well because they need that bend factor of vehicles going up and down those ramps. So they're not loosely tied in an area for vehicles.
Okay, very good. Well, lesson if you've got a jurisdiction you're working with that's putting up a parking lot, a parking structure, whatever, see if you can get them to lay out, ideally you want over a wavelength square of conductors spaced not much more than about 1/10 of a wavelength apart. That's a lot of wire or steel, but boy, it could make any antenna you put up that much more effective. And again, that could be the gain you're looking for to make up for those compromised field antennas.
There's another option you can do if you happen to live in Salt Lake City, Utah, which I did many years ago. You can go park yourself on top of the Kennecott copper mine. That makes great ground plane.
Oh wow.
I was surprised. Yeah. I didn't realize it until what's going on? Why is this antenna so good? All right. Are there any more questions? Any more answers? Okay. As I get stuff sent to me, I will include with when I send out my email. I appreciate everybody's time. The beauty of this kind of arrangement over a webinar is inclusive. In other words, you all get to participate, and that's why I like it. That's why we stick to it. There's been people suggest we do webinars. It just doesn't allow people to be personal like we have here. I like this a lot, and apparently you guys do too. We'll have more. I hope to hear from you guys as to what you'd like to see us do. And I see a lot of people has joined with the SEC ARES group. That's super awesome. With that, unless there's something more, I'm going to say 73s until next go around.
Thank you, Mark.
Everybody, thanks. Everybody stay well.
Thank you.
Thanks, Marty. Good to see you. See you Sunday.
Thank you and aloha. Thank you and aloha.